Hello, everybody. Welcome aboard. We're going to do review day today. We got a chapter 6 and 7 test coming up on Monday. I've had several requests to talk about the multiple choice from fall 2019. And that's where we're going to start. Little misleading here on this question. Question 12, I had 2 requests for, but it's not relevant for our test. And I only picked the questions I did think were relevant, so it looks like I skipped numbers 8 and 9. And 12 had nothing to do with this scheme, so originally it should have said 1 to 11. And let's start from the beginning. We have to know what acetylene is before we show up for this test. Acetylene is ethine. HCCCH, which makes it a terminal alkyne with a pKa of 25. That is relevant for this scheme. It will be relevant in your scheme too. I need to have a base that takes that H off and gives me a KEQ of 10 to the 10, which is the same as saying pKeq equals negative 10. They are the same thing. One's with the log scale and one's without. So I need to have an acid version of the base form plus H base, I'll call it. H attached to the base with a pKa of 35. How do I know that? Well, I'm going to take 25 and subtract the acid on the right side of the equilibrium and get an answer of negative 10. The only number that satisfies that is 35. 25 minus 35 is negative 10. So the H base I'm talking about is the only acid with a pKa of 35 that we know of, and that's hydrogen, which means the base was hydride. There's only one answer that corresponds to hydride, and that is this one. And please keep in mind, there'll be some clues in these answers that you may have to use later. So there's the hydride. Potassium's a spectator. So step 1, we're deprotonating to make potassium acetylide. So step 1 has made this for us. HCCC minus. That's acetylide, the conjugate base of acetylene. We're going to react it with isohexyl bromide. So it's going to react with bromine attached to a 5-carbon chain, 1, 2, 3, 4, 5, and a V on the end. And we're going to get a SN2 reaction. That's our synthesis reaction. It's the only synthesis we know so far. And you get a backside attack on the carbon with the halogen. And you get an alkyne that's still terminal. It's got a new bond right here to a 5-carbon chain. 1, 2, 3, 4, 5 with a V on the end. And the nomenclature of this, and yes, nomenclature in and of itself is not important, but we can't do any of these questions without it. So I get students saying, oh, I just skipped the nomenclature. It's not that important. Well, then you can't answer any questions. That's all I'm saying. So yeah, nomenclature is fundamentals. We can't talk organic chemistry unless we know nomenclature. And there's a methyl on 6. So we're looking at for the molecule that is called 6-methyl-1-heptine. I was not looking at the answers. I was looking at my molecule. 6-methyl-1-heptine is one of our answers. And it's the first one, yay. And then what is closest to pKeq in step 3? Now you don't know what vinyl potassium is. You're freaking out right now. I told you there are some clues on this page. Vinyl potassium is right here. And we know what a vinyl is. A vinyl is a CH double bonded to a CH2. So here our acid is still pKa 25. It's reacting with this base, the vinyl anion, to create H2C double CH2 with a pKa of 45. It's an alkene. Yes, we have to know how pKa's like we're going to use them on every test. I've said it before. I'm going to keep saying it. pKa's never go away. Stereocenters never go away. Hybridization never goes away. So when we learn these things, they're the fundamentals, and we learn them so we can use them in the future. That's why falling behind in this course is so dangerous, because you can't learn the new material without the old. And, well, I'm not making that. I took the proton off. Sorry. All this pontificating has distracted me. We made a terminal alkyne, and it's 7 carbons long, 2, 3, 4, 5, 6, 7 with a V. So we've got that. And then that's this is just step 3, people. 3 made that anion, and 4 is going to react with R2-chloropentane. I want to see if you know that this is a backside attack on an R stereocenter. You don't have to draw it properly. In fact, on the test, don't do that. Just don't do it. Draw a version of 2-chloropentane. Just keep in mind it's R. And when you're done, the backside attack flips the stereocenter. It's in the lecture notes. It's a fact. Backside, I'm not going to show the mechanism. We don't need the mechanism, but it's a backside attack on an R. It's going to be an S when you're done. You don't even have to draw the stereocenter. It's going to have a bond to the CCCC. 7 carbon chain starting with the first alkyne carbon. 1, 2, 3, 4, 5, 6, 7 with a V. Now, what's the longest chain with the alkyne on the lowest possible number? I don't know. I better figure it out. 1, 3, 4. Methyl on 4. 5, 6, 7, 9, 10, 11. So 4,11 dimethyl. That might even give us the answer. How many 4,11 dimethyls are there? None? That's not good news. Did I miscount? Oh, it's 10. It's a 10 methyl. Sorry. 4 and a 10. 10. 4,10 dimethyl undec 5-ine. 4,10 dimethyl undec 5-ine. Oh, there's an R and there's an S of the same. So we have to also know that the R is now S. Don't pick the R. You flipped it. And that makes the S the right answer. And that's where we're at now. I think you can imagine how I don't have to make a lot of changes here. I just change the words a little bit and all the answers are different. Like change that to isopentyl and change this to R2-chlorohexane, and we have a whole new set of questions. That's what's going to be happening. Giving away some good stuff there. This is product 2. Product 2 is going to react with sodium and ammonia. Now, that is a reduction of an alkyne to a transalkene. So I need the transalkene that has the S stereocenter, because that's not involved in the reduction. The reduction happens here, and this becomes trans. H on one side, H on the other side. You don't have to draw it. So I need the combination of the same name, 4,10 dimethyl, undec something 5-ene. So let's highlight all the answers that have 4,10 dimethyl undec 5-ene. 4,10 dimethyl undec 5-ene. There's 1. There's 2. Doesn't mean they're right. And we have the R's. They're not good because they have the wrong stereocenter, but the S's There we go. So we're down to 4 answers. And we need the one that's E. E and S. E and S. It's the only one that's E and S. Yeah, that's the only one right there. Okay. And then we're asked for during the mechanism in step 5, there are 2 acid-base reactions with the same KEQ. What is the KEQ? Wow. Step 5 is the sodium and ammonia reduction. And I'll just remind you, we don't have to know the specifics of what the molecule looks like. One of the acid-base steps is that one, and the other one is later in the mechanism, this one. And they both become alkene in the mechanism when they react with ammonia. NH3 is ammonia. And so they both make, with an H here, and this one makes RCCC, also with an H there. The key thing is we have a pKa of 45 from something that had a pKa, ammonia, pKa. Oops, no. Yeah, sorry. pKa of the reactant is 40. pKa of the product's 45. pKeq, 40 minus 45, -5, but we're not asked for pKeq. We're asked for KEQ. 10 to the negative -5. Pick the answer that's 10 to the 5. Got it. Okay. So far, so good, I think. And you want to see more of the page? Why not? See the whole deal. And we don't know what question number on. Well, I look for product 4. Product 3. What was product 3? It was that E alkene, right? We didn't draw it, but it's an E alkene. And I'm just going to draw it because it looks like it goes 2 places. Product 3. And we already, it's product 3 was 410 dimethyl 5-ene 5 4 3 2 1 5 6 7 8 9 10 11, and 3 going to 4 will be these 2 products. Double bond there. Double bond there. Why? Because this is called ozonolysis. And what happens during ozonolysis is you cut the double bond in half and you put a carbonyl there and a carbonyl there on both halves. So there's that and there's that. And these are both aldehydes. So I'm looking for some critical thinkers out there who can figure out which products are aldehydes from these names. And they're all aldehydes. You know how I know? Here's your preview for 242. And molecules ending with Al are aldehydes. So that really didn't solve anything for us. And let's see. This is a 1, 2, 3, 4, 5 carbon aldehyde with the methyl on 2. 2-methyl pentanal. 2-methyl pentanal. Check. And this one is 1, 2, 3, 4, 5, 6. And if you haven't guessed by now, aldehydes and any functional group with an oxygen in it have the highest priority in organic chemistry. This is a tidbit that you should remember. The more bonds to oxygen the functional group has, the higher the nomenclature priority. So when we hit alcohols in chapter 10, that'll be the highest priority for us in nomenclature this semester. But then we hit chapter 16 with aldehydes and ketones in Orgo 2, and they have a higher priority. because they have 2 bonds to O. And then later we hit carboxylic acids where that same carbon has 3 bonds to O, and you say, we've reached the top highest priority in nomenclature. So anyway, just for now, the more bonds you have to O, the higher the priority in nomenclature. Take that to the bank. So once again, we have a 1, 2, 3, 4, 5, 6 carbon aldehyde with a methyl on 5. Hex-an-al, methyl on 5. Check. So molecules 1 and 5. Got to pick the right combination of 2. And product Y. I didn't even ask about product 5. I probably did. We might as well do it since we're here. I just didn't copy the question over. It's still a good question. OSO4 and NaHSO3. That will make a vicinal diol. This will be 5. These 2 were 4. And this will be 5. And where the double bond was, you have one OH on a wedge and the other OH also on a wedge. So you'd pick a molecule that has, they're not here. I keep forgetting that. So something about diol. 6, 7, 11, 1, 2, 3, 4. That's 5. 5, 6, diol. And I don't think I'm going to ask that question on your test anyway, because there's stereocenters there, and it's kind of advanced. I'm trying to keep things a little more straightforward during these pandemic times. I know it doesn't seem like it, but I'm trying. All right. So product 1 is also, where was product 1? We never labeled it. It was this one right here. And it is going to react with HB-Sia2 and hydrogen peroxide and hydroxide. So that'll make product Z. And then the mercury version of the same reaction. So we'll go to Z. And we'll go to Y. We'll do Y first. Alphabetically, it's first. That'll put a carbonyl on the inside carbon. And the hydroboration oxidation puts a carbonyl on the outside carbon, the terminal carbon. So I need in Y, carbonyl there. And then let's just count. 3, 4, 5, 6, 7, methyl there. And on this one, I want the carbonyl here. 1, 2, 3, 4, 5, 6, 7 with a methyl there. So that's a 6-methyl aldehyde from a 7-carbon aldehyde. And I think Z will be the, let's see, find Z. 7, did I say 7? I think I said 7. Yep, 7-carbon aldehyde. So it's down to, it's just this one. There's only one 7-carbon aldehyde here. Oh, there's another one. 6-methyl was better. I don't know why the font was smaller. And that's, to fit them in 2 lines, I guess. Yeah, this has the methyl on the wrong position. This is a ketone on 2 and a methyl on 6 of the same. So 7-carbon ketone. 7-carbon ketone, that would be one on 2, but methyl on 6, not 5. There you go. 6-methyl heptan 2-one. And that's 3-one. Carbonyls on the wrong position. Here the methyls on the wrong position. All of them. And those are good questions. So I'm looking to have 6 questions like these. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to cut 2 out. Probably 1 pKa question and maybe 1 of these products. And that gets it down to 6. So that's the 6 you're looking for, okay? I had a request for question 12, but it's by accident, it doesn't belong here. And it's radical stability, which is chapter 8. So you'll notice there's a table in the exam with bond dissociation energies on it. Please ignore that. That's chapter 8. That table will not be used on your test until test 4. So this is a nice place for a break. I'll let you know where we're going to pick up after break, and feel free to email me any requests. I will be checking my email when I run out of questions, and hopefully I'll have something else to do. We've had a request for both, not surprising, that we've had a request for both parts of part 2. This is the first part of part 2, and then that probably takes a whole segment, and it's good review. It's got all the chapter 6 reactions. And then the chapter 7 part of 2 is here, and it kind of relates to what we just did, doesn't it? With a little more involved. And there's these isotopes that are going to pop up. I don't want you to be totally shocked when we see things like deuterium and tritium. So yeah, don't make Monday your first day to see those. So we'll see you after the break, where we start here, Fall 19, part 2. See you soon.